Good afternoon everyone. So today's session I will discuss about an Bellman-Ford algorithm. So what is this Bellman-Ford algorithm is that, so all of you know what is this Dijkstra's algorithm will do. What is Dijkstra will do? It will, from a given source vertex, it will compute the shortest distance to all other vertices from the source vertex. So suppose that is also called as a single source shortest path problem. In the Dijkstra, if I am applying for this particular graph, if the source vertex is 1, it will compute the shortest distance from this source vertex to all other vertices. So how it will start, all of you know that how Dijkstra will work. So it is 1, okay, I'll start with the source vertex. Among these two, it will identify which is the smallest one, that is this path is the smallest path. So 1 to 3. So it is 1 to 3 is equal to 5. Now it will check from 3, are you having a distance to the 2? But there is no distance to the 2. Therefore what it will do there means it will consider this particular path. So it will consider that 1 to 2 is equal to an 7. 1 to 2 is equal to an 7. So getting my point, what it will do? So first it will consider among this which is the shortest path. So 5 is the shortest path. So it will choose from 1 to 3. Now from 3 it will check whether are you having an edge from 3 to the 2. There is no edge from 3 to the 2. Therefore what it will do? It will consider the one more option, that is it will move from vertex 1 to the vertex 7. So this is the distance what you will get in case of the Dijkstra's algorithm. Now we will consider the Bellman-Ford algorithm. In case of an Bellman-Ford algorithm, the disadvantages of this Dijkstra is that it doesn't compute the shortest path if you are having a negative weights. Actually, what is the shortest path from 1 to 3? It is 7 minus 5. It is 2. Okay. But what it is showing? 1 to 3 as a 5. Okay. So when you are having a negative edges, the Dijkstra's algorithm will not work properly. Okay. So that is the disadvantage of using a Dijkstra's algorithm. So in order to overcome that one, the Bellman-Ford algorithm we are using. So Bellman-Ford algorithm will also do the same thing what the Dijkstra will do. It for a given source vertex, it will compute what is the shortest path from the source vertex to all other vertices. But it works for a negative edges also. And it uses the concept of the dynamic programming. Whereas your which is that Dijkstra algorithm will use as a concept of the greedy technique, and this will use as a concept of an dynamic programming. So what this Bellman-Ford algorithm will do, according to the Bellman-Ford algorithm, how it is I will explain it later. So the distance from an 1 to 3 is 2 and distance from 1 to 2 is 7. That is according to the Bellman-Ford algorithm. So how this Bellman-Ford algorithm works is, so it will check that for each of the incoming edges. See how Dijkstra work? For an outgoing edges, it will check which is the minimum. Correct. Whereas your Bellman-Ford algorithm uses for the incoming edges. Dijkstra uses for an outgoing edges which is a minimum cost edge. Whereas the Bellman-Ford algorithm works on the concept of the incoming edges. Now what it will do, it will consider every vertex. Anyhow, source to source will be an 0 only. It will check that for each of the incoming edge, it will check what is the distance till this plus the distance from here to here. So 2 is having one incoming edge. What is distance till 1? 0. And 1 to 2 is 7. So the distance from 1 to 2 is nothing but an 7. Now it will consider this one. How many incoming edges are there? There are 2 incoming edges are there for the 3. One is from the 1 and the other one is from the 2. Now what it will do? It will consider this incoming edge. Then it will check what is the distance till 1 plus 1 to 3 distance. What is the distance till 1, 0, and here it is 5. Okay. So for each incoming edge it will consider. So if it is considering this incoming edge, what is the distance it is getting? 5. Now it will consider for this incoming edge. So this incoming edge is coming from 2. What is the distance till 2? It is 7. Or 2 to 3 is minus 5. So how much it is? 2. So it is 2. Getting my point? So minimum of this one it will consider as the distance from source vertex to that particular vertex. So that is what I have written it here. So what it will do, it will consider this one. I'll consider for this vertex 3. So distance, previous distance to the u. So it is min of, what is the previous distance to the 3? Are you having edge from 1 to 3? Yes. How much it is? 5. Previous distance to the 3. It is direct distance from 1 to 3. Now min of for each of the incoming edges. Now this is for each of the incoming edges. It will consider that how many incoming edge it is having? Here and here. The distance till this, that is 0 plus then the edge distance 5. Then one more incoming edge it is having. So for this incoming edge, so distance till u 7, then here to here minus 5. So which is the minimum among this? So it is 5. Minimum among this is 2. So among this, which is the minimum? 2 is the minimum. So that is how your Bellman-Ford algorithm works. So Dijkstra, how it works? For each of the outgoing edges from the vertex, it will consider which is the least scorch edge for each outgoing edges. Whereas the Bellman-Ford works in the reverse order. It works for each of the incoming edges. For each of the incoming edge, which is the one which is giving it to the shortest path compared to the previous. This is the previous distance. Previous distance. What is the previous distance to that 3? It is a distance, direct distance from source to the 3. That is 1 to 3, that is 5. Now, min of for each of the incoming edge. How many incoming edges there for the 3? There are 2 incoming edges are there. Now, for each of these incoming edges, it will compute which is the shortest path. So, finally, what is the shortest path it got? 2. That is 1 to 2, the distance is 2. Whereas, if I use a Dijkstra's algorithm, 1 to 3, we are getting the distance as an 5. So, that is the disadvantage of your Dijkstra's algorithm. It doesn't work properly for an negative edges. Whereas, the Bellman-Ford algorithm consider the negative edges also, and Bellman-Ford uses a concept of dynamic programming, and Dijkstra uses a concept of an greedy technique. And all of you know that many times I have explained you what is a dynamic programming concept. Dynamic programming is a concept where I will consider a small subproblem, solve it, its result is stored in a table, and use that table for solving the next subproblem. Again, their result is stored in some table, use that one for solving the next subproblem. That is the concept of your Dijkstra. Now, I'll consider the algorithm. So, algorithm you will understand better when we will solve the problem, but anyhow I will finish this. So, it is very simple. What is that? For I is equal to 1 to n, initially the distance vector, I am considering it as an cost of s to I. So, that is, if I will consider the same example. So, initially what is my distance of distance vector? It is nothing but how many vertices are there? 3 vertices. 1 to 1 will be 0, and 1 to 2 will be an 7, and 1 to 3 will be an 5. So, initially this is the distance vector. That means from the source vertex to other vertices. From source to the 2, how much? 7. From source to the 3, how much? 5. So, whatever the distance is there, that is the initially I am transferring it to the distance vector. Okay, whatever the direct distance, if it is an infinity, it is an infinity, like that. So, then what I am doing for k is equal to, because source vertex we are leaving, so it is starts from second, okay, second step, 2 to n minus 1. So, now what I have to do, for each of the vertex u which is not a source vertex. For each of the vertex, which is not an source vertex, check that it is having any of the incoming edge, and u has at least the one incoming edge. So the vertex which is not a source vertex, these 2 and the 3, and which has at least one incoming edge. This is having one incoming edge, this is having a 2 incoming edge. If it has an incoming edge, then what I have to do for each of the incoming edge? So I am checking it for the u. Here it is the 2. Okay. So now I value will be an 1 initially. 1 to n we are considering. So are we having an edge from 1 to 2, then 1 to 3, 2 to 2, 2 to 3 to 2, 4 to 2, 5 to 2. So any incoming edge what we are having to the 2, okay, because I am considering the u here. So for all the incoming edges, so from any vertex to the u indicate what? Incoming edge, not the outgoing edge. Any vertex to the u indicate what? Incoming edge. Okay. So for each of the incoming edges, what I am checking here? I am checking that if the previous distance to the u, that is what I got explained you here. If the previous distance to the u, if it is greater than distance till I, because I am having edge from I to u. We are having an edge from I to u. So the distance till I plus cost of I to u. If this is minimum, then your distance vector to the u is modified with this. For example, if the previous distance itself is a greater, don't update it, it will be as it is. Suppose if this is minimum, then you consider the same whatever I have written, min of min, same thing I am writing in a different way, because if I'll write like this, again I have to use a min function. I have to call a min function, write the statements in the min function, all the things we need to do. So just to avoid that one, what we are doing, I am checking that if the previous distance is greater, then I am considering that. Otherwise, this is the incoming edge you are having, I, u. So distance till I plus cost of I to u. If this is minimum, then that will be copied to the distance. Otherwise, if this is greater, then no updation will be done. It is the previous value only. Okay. So that is your algorithm for an Bellman fold. So it's very simple algorithm. What we are doing here is, so initially we are considering the distance vector as a whatever the direct distance is there from the source vertex to all other vertex. Next iteration what I am doing, now I am checking for an every vertex u which is not a source vertex. Now if it has any of the incoming edge, then I am checking that whether previous distance to the u is a minimum or distance till I plus cost of iu is minimum. So whichever is the minimum, if the previous distance is a minimum, that will be considered. If the distance for incoming edges what we have taken, if that is the minimum, then that will be considered. So that is how your Bellman fold algorithm works. So this you will understand better if you will see some of the examples.